Good evening, everyone. I would like to invite Arun sir to start the session.
Thank you, ma'am. Hello, students. Welcome back to the bridge course. Today we'll continue with current electricity and also we'll continue with the logical sessions, logical reasoning part that we discontinued yesterday. Students, this was the given homework. This question was given as homework. Hope you tried. If you haven't tried, think about it. I'll give you another minute. We'll solve it now. Good evening, Shashank. Hello, good evening, Ria. All right. Have you tried this question? Okay. Yeah, good evening, Akhilesh. Oh, Shashank, already with an answer. Good. Excellent. Okay. How about others? Have you tried? You would have made an attempt at least. Answer is not important. The attempt is important, students. All right. Let me go ahead. So, students, over here, there's an infinite ladder network. Why is it called a ladder network? Because it looks like a ladder, a Nichina kind of network. So, if this is X, let's say, what is X? The equivalent resistance between points A and B of this ladder network is X. If I remove this 1 unit, the equivalent resistance of this part would also be X because this is also an infinite network. So this X is in parallel with 2, which is in series with 2 again. That is also equal to X. So we get the equation like this. So equivalent resistance is X. What is the RP? R
Sir, you are not clear. Your voice is not clear. Excuse me, sir.
Two into X by X plus 2, which is this part. Sorry for the interruption, students. All right, so we get a quadratic equation. We simply solve it. We know the formula for the quadratic. We have framed an equation for the physical situation. So we get x square minus 2x minus 4 is equal to 0. X is equal to minus of b plus or minus b square minus 4ac by 2a. I substitute the values of a, b, and c. All I get is 1 plus root 5 as the answer. Is this what you have done, Shashank? Hope you have done the same thing. All right. All right, students, have you followed this method? If you have followed, there is yet another problem. We can make an attempt now. Shashank, have you done the same thing? And others, have you followed the method? Type yes or no in the chat box. Students able to hear me? All right, let me go for the next example. Here is the next example. Where we have got two different resistors, 2 and 3, connected in a ladder pattern. Excuse me, ma'am, is my voice audible?
Yes, sir. You're audible.
All right, ma'am, thank you. All right, so now in this case as well, what we do is let the equivalent resistance between A and B be X, and RP is equal to R1 R2 by R1 plus R2, 3x by x plus 3. So this 3x by x plus 3 is in series with 2, which is equal to x again. So 5x plus 6 by x plus 3. Okay. Shashank, have you got the same equation? X is equal to 3x by x plus 3 plus 2. Because the answer seems to be different. Have you followed the same method, Shashank? Okay. Seems like you have got another method. But this is the only possible way of solving this ladder network. So I've got I cross multiply x into x plus 3 is equal to 5x plus 6. X square plus 3x is equal to 5x plus 6. X square minus 2x minus 6 is equal to 0. Formula for the quadratic equation, I substitute the values of a, b, and c. So I get 1 plus root 7 as the answer, discarding the negative root, negative value of x. Is this okay, students? Is the solution okay? Type yes or no in the chat box. All right, yes. How about others? All right. All right. If it's yes, yes, Akhilesh, that's absolutely right. Good. Excellent. How about others? Ria, is it okay? Is the method okay for you? Is it clear? And Nandini, please make an attempt. Please interact. Nothing wrong in going wrong. All is important that you understand the method so that you can apply it in future. All right. If that's clear, I'll conclude current electricity with this. Let's move on to logical reasoning. Syllogism. We have understood what a syllogism is yesterday, but I'll just put the quick statement quickly. Here is the statement we did discuss yesterday. Syllogism checks basic aptitude and ability of a candidate to derive inferences from a given statement using step-by-step methods of solving problems. In simple words, it is about the ability to draw correct conclusions from the statements. Now let us apply this reasoning in physics. For instance, consider this question. It's an interesting question, students. Follow the question carefully. A box is being pulled across a horizontal floor with a horizontal force of 30 Newton. So there's a box on the horizontal floor, which is being pulled with constant force of 30 Newton at a constant velocity of 4 meters per second. There's a force applied and the box is moving with constant velocity. Find the magnitude of the force of friction acting on the object. Interesting question, students. Think about it. The question is, is the statement clear, student? Is the situation clear? There's a box which is being pulled with a constant force of 30 Newton at a constant velocity of 4 meters per second. All right. So statement is clear. Good. Now we need to find the force of friction acting on the object. How do we do that? So we apply Newton's laws. But look at the contradiction, students. A seeming contradiction. అని అనిపిస్తుంది తప్పు అనిపిస్తుంది బట్ తప్పు కాదు. ఫోర్స్ అప్లై అవుతుంది బట్ కాన్స్టెంట్ వెలాసిటీతో మూవ్ అవుతుంది. ఫోర్స్ అప్లై అయితే యాక్సిలరేషన్ తో మూవ్ అవ్వాలి కదా. ఒక పార్టికల్ కాన్స్టెంట్ వెలాసిటీతో మూవ్ అయితే ఫోర్స్ ఉండకూడదు కదా, దాని మీద నెట్ ఫోర్స్ 0 ఉండాలి. Do you agree with this? If a particle is moving with a constant velocity in space or in motion, net force on the particle should be 0. You all agree with that? Okay, Shashank agrees with that. How about Akhilesh, Nandini, and Priya? Do you all agree with that statement that if a particle moves with constant velocity, net force on the particle should be 0? Make it quick, students. Give me a quick response. All right. Priya says yes. All right. All right. Yes and yes. Good. Now, let us see how do we reason it out. And we have to find out force of friction. So Newton's first law says object moves with constant velocity when net force is 0. In the question, object is moving with constant velocity. That means net force on the particle is 0. Conclusion, force on the object must be 0. That means force of 30 Newton must be balanced by some other force. The only possible force is friction. So friction is 30 Newton in opposite direction. In opposite direction to the velocity. Or opposite direction to the force applied. Is the logical flow clear, students? All right. So I'll repeat the logical statements. I'll repeat the reasoning. I've got a box which is being pulled with 30 Newton but moving with constant velocity. We need to find the required to find is force of friction acting on the object. From Newton's first law, we know that if a particle moves with constant velocity, the net force on that should be 0. So in the given question, the box is moving with constant velocity. That means net force on the box is supposed to be 0. There's an applied force of 30 Newton, which is counterbalanced by another force, which is friction. So friction is equal to 30 Newton. Pretty simple, right? All right. Now let's go for another example. A bomb at rest explodes into 2 parts. And one part moves at 80 meters per second towards the east. What is the direction of velocity of second part? So there's a bomb which explodes at rest. The bomb was at rest. That's very important. It was at rest. It exploded into 2 parts. One part moved towards east with some velocity. We need to find the direction of velocity of the second part. We don't need to find the velocity of the second part, speed of it, only the direction of velocity of the second part. In which direction would this move? Is the question. I hope the question is clear. Excellent, Shashank. But could you also put the reasoning? That's absolutely right. How about others? I want others also to make an attempt, think about it, and let me know the answer in the chat box. All right. Now let's see how do we logically conclude what the direction should be. Conservation of momentum. The total momentum before and after collision must be equal. So before and after explosion, the momentum should be equal when the net external force is zero. So in that particular direction in which the net force is zero, so let's say horizontally on the bomb, there's no net force in the horizontal direction. So in horizontal plane, the net momentum, total momentum before and after explosion should be equal. In the question, there is no external force on the bomb in the horizontal plane. So the motion of the second part must be just opposite the direction of the first part. Momentum must be conserved. So as Shashank has very rightly mentioned, if this moves towards east, for momentum to be conserved, because it was before the explosion it was zero, after the explosion it also it should be zero. So momentum should be conserved. So if it moves towards east, the other part should move towards west. Excellent, Shashank. All right. Now let's students, can you think of a couple of more examples? Think of such examples which you have come across in your syllabus where we can apply this reasoning, where we can apply a law and conclude. It could be particle under gravity or projectile motion or a car colliding. Or if you think of some example, can you think of an example? I'll give you a minute. Think about an example, such an example, students. Yes, Shashank, yes. Yes, there we can apply. But on a rocket, there is an external force acting on the rocket, students. Okay, unless rocket is moving with constant speed or velocity, not speed, velocity, there's a force acting on it. One is acceleration due to gravity, force due to gravity, and the force of propulsion. But that's good thought. All right, think about it. Let's continue with the session. Now let's talk of importance of prepositions in understanding of statement, students. For example, if an object is moving at 20 meters per second, and we say that its speed increases to 25 meters per second, what does it mean? And another statement says an object is moving at 20 meters per second and its speed increases by 25 meters per second. So what is the difference between these two? What is the final speed of the object, students? ఈ రెండిట్లో డిఫరెన్స్ ఏంటి? ఒక దాంట్లో మనం 2 అంటున్నాము, ఒక దాంట్లో బై అంటున్నాం. Its speed increases to 25 meters per second. In the second case, its speed increases by 25 meters per second. So in which case, what's the final speed of this object as per the statement? Can you tell me what the final speed of the object in this as per the statement is? Think. When I say it is 225 meters per second, final velocity is 25 meters per second. But when I say it's by 25 meters per second, final velocity is 20 plus 25, which is 45 meters per second. Is this difference clear, students? It's very important difference, which we come across not just in kinematics, but in hydrostatics, in thermodynamics, in every part of physics. Such prepositions do make a difference in the calculations we make. So it is very important that you understand the difference between to and by. When I say speed increases to 25 meters per second, that means final speed is 25 meters per second. When I say speed increases by 25 meters per second, that means I'm adding another 25 meters per second to the initial speed of 20. And this is not important, is important not only in physics and math, but in daily life as well, students, where we come across situations in daily life where we need to understand the difference between to and by. All right, I hope this is clear. May I know it's clear or not? Please type in the chat box, yes or no. All right, Shashank says yes. Akhilesh says yes, good. All right. Okay, yes. I'll go ahead. Yeah, another difference from and to. Whenever there is a change from initial value to a final value, the difference is the incremental change. We say that the value increases by the difference. We say the value increases by that particular difference. Students, can you think of another example where you have difference between two and by? Can you think of a sentence where you can make a difference, where that makes a difference? All right, you can come up with an example next time, but do keep this in mind. This is very important for us, not just in math and physics, but in daily life as well. All right, you can keep this in mind. All right, good, Shashank. All right, now let's look at this one. When do we use the word all and when do we use the word some? When we use all is an inclusive term where when each and every object we consider satisfy the given condition. So we use all only when each and every object we consider satisfies the given condition. Even if there is one exception, even if there is one object that does not satisfy the condition, we cannot use the word all. In such cases, we use the word some. Is this difference clear, students? ఆల్ ఎప్పుడు చెప్తామంటే అన్ని ప్రతి ఒక్క ఆబ్జెక్ట్ మన కండిషన్ సాటిస్ఫై చేయాలి. ఒక్క ఆబ్జెక్ట్ కూడా కండిషన్ సాటిస్ఫై చేయలేదంటే అప్పుడు మనం ఆల్ యూజ్ చేయలేము. దెన్ వీ హావ్ టు యూజ్ ద వర్డ్ సమ్. సో దేర్ ఇస్ అ డిఫరెన్స్ వెన్ యూ యూజ్ ఆల్, డిఫరెన్స్ వెన్ యూ యూజ్ సమ్. So technical differences, when each and every object satisfies the condition, we use the word all. When even if one object does not satisfy the condition, you've got hordes of objects, but even if one object does not satisfy the condition, we use the word some. All right, students, we'll end with this. We'll see you tomorrow again. Good night and good luck.